Hello and welcome to part 6 of Dev Maths and Stats Refresher Course, Lecture 1, in which we start looking at some different ways of doing algebraic manipulation. So, we can look at a few basic techniques, and if you do need lots of practice, then I've recommended some textbooks. Those are full of examples of problems, and remember that you should really be able to do all this just with pen and paper, or certainly you should not have to rely on Maple to do it. So I'm only using Maple because it's just quick to do as a lecture. So these are the 4 sections we'll look at. We'll start with something called the golden rule. Very basic idea, and this is this famous old idea that whenever you have an equation, you can do whatever you like as long as you do the same thing to both sides. So that's a golden rule. So here I'm going to define an equation. Now, Maple lets you define an equation like this, so now it knows that equation 1 refers to that simple equation. Now, later we will do solving equations. For now, I will tell you the solution is x is 4. You can check this by, if you put x is 4 here, I have 6 times 4 is 24, plus 4 is 28. 4 times 4 is 16, plus 12 is 28, so it's correct. With Maple, you can use the substitution command, so it substitutes x is 4 into equation 1 and just verifies that it's correct. Now, there's only one solution here. If I try anything else, it doesn't work. So these numbers are not solutions. 4 is the only solution here. Now, the golden rule idea is that 4 remains a solution as long as we follow the golden rule. For example, we can add on a number. So this is equation 1, adding 75 on both sides. So you can see I've added 75 to here and to here. So instead of 4, I've got 79, here I've got 75 is 87. If I substitute 4 in, I find it's still correct. As well as adding on numbers or taking away fixed numbers, I can add on some more unknowns, variables. Like I can add another 13x by doing this. So to here I've added 13x on both sides. So instead of 6 or 4, I've got this many. And so it's now looks quite different, but still x is 4 is a solution. I could divide it. I can multiply and divide it. So here I've multiplied everything by 3. So multiply all these numbers by 3, it's still, solution is still 4. I can multiply it by 2x. So here I've multiplied by 2x and 2x. I've expanded it. We'll check you can remember this in a moment. But here's a much more complicated equation, but still 4 is a solution. That's still correct. And I can even do something like divide by a whole new variable q. So both sides of this fancy equation are divided by 7q squared minus 3. Put in x equals 4 and still you get the same thing on both sides. You can even go crazy and start using exponentials and logs. So I went back to equation 3 above. So start with equation 3 and do 4 to the power of that. So 4 to the power of equation 3, wherever that was, that's this. So 4 to the power of this is equal to 4 to the power of this. So you get that kind of very difficult equation here, but by substituting x equals 4, you work that out, quite obviously it comes to the same thing. So, the golden rule guarantees that the solution will remain valid, but it's not quite so simple, but because you can go wrong and still introduce some extra solutions. Now, if you remember above, x is equal to 0, x is equal to 0 is not a solution of this equation. If I put 0 in here, it's incorrect. I find 4 is equal to 12. So this is not a solution. But I followed the golden rule all the way through, and now I find that 0 is a solution. So you can't lose solutions, but you can gain an extra solution. If you look back through the stages, see if you can check where did that unwanted solution arise. So have a look back, where did this go wrong? So pause for a second and have a look. Then let me point out to you where it went wrong. It was actually up here when we multiply by 2x. So here, when you multiply by 2x, you have to assume that x is not 0. Because if x is 0, then whatever these other things are, there will be a solution here. We can apply the golden rule to solving linear equations. So let me show you an example of that. This is the equation we started with just then. Previously I told you that 4 is the solution, but now I will show you how you can find that solution. So remember that what you do is you want to isolate the variable x on one side. So let us choose the left hand side. So if I choose the left, I want to remove this 4 here. So I can subtract 4 from both sides like this. So according to the golden rule, the answer is still the same. Now I can remove this from here by subtracting 4x from both sides. Like that. Again, the answer should be the same. And finally, just divide by 2 and you get the answer. And once you have an answer, it's always worth substituting back in to check that it works. So divide by 2, you get x is 4, substitute into the original equation, and you get 28 is 28, so it's correct. This, remember, means the last calculation result. So take the last calculation result, substitute it back into the equation. Okay, another example. So here, again, let's isolate the variable on the left-hand side. So we need to remove this. So to remove negative 89, we need to add 89. Add 89 to both sides. So add 89 here, add 89 here. So here it's a 54, 43. Then to remove the 36q, you need to subtract that. So subtract 36q here and here. Let's get this. Finally, divide by 13. Q is 11. Substitute back into the original equation. You have 450 is 450. So this is correct. Q is 11. And one final example, just to give you something that looks difficult to start with. We have fractions. Personally, I always advise just clearing these fractions at the start. So we could multiply by something which is divisible by 12 and 3. You could multiply by 36, which would work okay, but 12 is easier because 12 you can divide by both 12 and 3. So if I multiply this by 12, I get this. So 12 times this, 12 times this gives you 5d, 12 times this gives you that, 12 times that gives you that. So, okay. And then the steps are the same. So let's remove this 5d by adding that. Then subtract this. And then switch the sides around as I did here. Let's get d is 60. So check back in the original equation, that's correct. So those are the ways you can apply the golden rule to solve any linear equation. Okay, next we'll go on to dealing with brackets, but thanks for watching.